Hi, my name's Eli Holmes. I am the lead of NOAA Fisheries Open Science Initiative, and I'm going to give you a brief introduction to NOAA, to JupyterHubs and containerization, and explain why they streamline and accelerate scientific innovation. So, containers, um, in the context I'm going to be talking about them, are these lightweight and portable. It's like a package of the environment that you need to do um, some work. So, like on my computer, if I were to set up a new computer, I would have my operating system installed. I use R, so I'd install R. Then I use RStudio, install bunch of packages. Um, and that would define the environment that I need to do a particular analysis. And now imagine that weren't installed on kind of my computer, but imagine that were like in a container, a box, this portable thing, and I could just grab that. I could put it on your computer, log in and use your computing, but I've got my environment there. Or I could take that, put that on a virtual machine. And that's kind of like what containers are, what images are like. They're these lightweight, portable environments that you can move and spin up in different places. And the nice thing is they're completely isolated from each other. I could run multiple on my laptop or on, say, a virtual machine. And to run these, you need something that will run these kind of images. And then then we'll have some infrastructure like a computer. I'm going to talk mainly in the context of virtual machines, and we're running these on virtual machines, but you don't have to run these in the cloud. You definitely can just run these on kind of any computer. So, a really popular container server for scientific applications is JupyterHub. And within these scientific applications, our images will often look kind of like this. So let's say that I wanted an image for doing some geospatial analysis in Python. I want to do some machine learning. So for that, I'm going to have a base image. I'm going to use here a Pangeo, which is a base environment for geospatial analysis in Python. And then maybe I'll add some machine learning tools to that. I'll install those, and then maybe some more Python modules. That's going to define my environment, my image, my container. Maybe an R user, I would have a different container with the tooling that I need. And it doesn't have to be just limited to like things like Python, R, Julia. You can also have C++ and different sort of binary things you need to install. Basically, if you can set up your environment by installing things in a Linux machine, you can create a Docker image and bundle that up as a container. So JupyterHub is going to run these containers for us, these scientific computing containers. And then, because the name is JupyterHub, you might think, oh, that's just Jupyter Notebooks. That's just Python. Not at all. No, it's the Container Hub is the Jupyter Hub is an engine for running these containers. It can run R as well as other things, as well as Python. Also, we don't have to be interacting with our environment using Jupyter Notebooks. Certainly, that's very common in Jupyter Hubs, but we could also be interacting with the environment from RStudio. For example, if we're working with R users, they'd be more familiar using RStudio. Or we could use Visual Studio Code. A lot of people like that. We could use MATLAB if our image is a MATLAB image. So why are Jupyter Hubs so popular? Well, they remove the whole software and package installation problem, even for complex environments. So, you don't have to worry about the different team members, making sure they can install everything or making sure everyone's using the same packages, the same version of Python or R or whatever. Because you're using a container image rather than having everyone install things individually on their laptops. You know that everyone's in the same environment. And also, they don't have to worry about installing things. In a Jupyter Hub, you just select, I want to use that environment. Bing! You spin up in that, and you're good to go. I teach a lot of workshops, and this is a game changer because nobody has to install anything. Everyone shows up, they sit down, go to a URL, they're inside the hub, they're ready to go. I know all my tutorials are going to work because everyone's in the same environment. Another situation is if you're people on the team, maybe they're on computers where they don't have permission to install things on their computer. They have to go to IT to install that. That can create a lot of barriers, frustration on both sides. The person who wants it installed and the IT is trying to help them, but maybe doesn't know how to install everything. So this can really speed things up for a group of people who want to be using the same development environment. Jupyter Hubs, like I said, very widely used. You're going to see these like all over. I was, conference recently. I think 75% of the workshops were being run on a Jupyter Hub. You can, so Jupyter Hubs are open infrastructure. They're not like specific to any cloud provider, AWS, Azure, Google, doesn't matter. You can install it on all of them. You can also install it on a bare metal server. So you could buy a computer, put it under your desk and install it on there. All works. It's very common. Some institutions manage their own Jupyter Hubs. I have managed them. It's not that hard. However, another option is a hub that's managed by an outside group, and 2I2C is a group that manages a lot of hubs for universities, NGOs, government, and I've worked a lot with the 2I2C hubs. So this is an example of a 2I2C hub that NASA OpenScapes has. This is used by the NASA data centers for all their workshops. They develop tutorials on this on how to work with big geospatial data in the cloud. So on the site here, it shows like what you would see if you logged into their hub, and you can see they provide a Python, R, a MATLAB environments, and these are geospatial environments that are all set up to work with data in the cloud. So it has all the tooling that's needed. Don't need to install anything when you spin it up. And right here, it says resource allocation. And this part is there's a drop-down menu where you specify what size virtual machine you need for your work. Now, why would you need a different size virtual machine? Well, if you were loading a really big data set into memory, you're going to need more RAM to do that. And so in a Jupyter Hub, you just select what size machine you need for the task at hand. This is different than so a Jupyter Hub is not like something where we have one machine and we're all in this same machine. We have these images and they're being spun up, and each person is getting their own virtual machine, basically. So if there are 5 people on the hub, we've got 5 of these machines spun up. If we have 100, we have 100. And each person is grabbing the size machine that they need, but they're all in the exact same development environment, same packages, same version of everything that they need. Another nice feature of Hubs is kind of a new feature in the newest version of JupyterHubs is you can bring your own image. So a team can develop their own Docker image and they can drop it right in here and spin that up. So like if these don't fit your purposes, you can bring your own. As I said, open infrastructure runs on all the cloud providers. Also, a nice thing is these images tend to be infrastructure agnostic. That means they will run on a Jupyter Hub, of course, but you could also spin it up with Docker on your computer or Bender or GitHub Codespaces or GitLab. So your community is not forced to only work in the Jupyter Hub. Where do these images come from? Well, there's some very well established community base images. So the Jupyter data science stacks and the Pangeo geospatial stacks, very big Python developed images. And then for the R world, there are the Rocker R stacks. And typically what you would do is you'd use one of these as a base image. And if there's extra packages or tooling, some other like, maybe you have some like special, program that you are binary, you run things through. So you might add that on top, but you build it typically off one of these base images. So yeah, so you can build your own, but again, typically people start here and they add things to that. You don't have to, but that's common. If you want to see a demo, you can go here to see a basic version to show you how to what it looks like when you spin one up. Or you can go here to see bring your own. I realize my video is blocking that, so you'll have to use that. Right, I hope that was useful.